All right, so I am recording this. I don't usually record when I review for something, but I will today. So hopefully the people that were not in school today because of the major snowstorm of 0.0 inches will be able to see this and have a good review. All right, here we go. Number 27. Is this all by elimination? This whole thing? It says addition, but again, when they say addition, that means elimination to us. Okay, so let's do some elimination. I'll tell you what, let's scooch this over a little bit. All right, so let's change colors. All right, what we want to do is we want to eliminate either the x's or the y's. All right, to tell you the truth, either one is pretty much just as easy to eliminate, but I would probably pick the y's to eliminate. Why would I do that? WHY, why would I do that? Why would I pick the y's to eliminate? What's easier about that than the x's?
They're already positive.
Yeah, you already got one positive, one negative, okay? So it's already there for you, so I don't have to worry about it, all right? But I got a 3 and a 2. They don't eliminate right now. If I add these up, these do not add up to 0. So what I got to do is I got to pick a number. I got a 2 and a 3 here. I got to pick a number, a smallest number. It would be nice if I picked the smallest number. You actually don't even have to pick the smallest number, but it just makes it a little easier. What's the smallest number that 2 and 3 divide into evenly? 6, right. So I'm going to multiply. I'm going to try to get this to be a 6y and try to get that to be a 6y. Yes. Yes. So what would I do to this 3 in order to make it into a 6? What do I multiply it by to make it a 6? A 2. So I multiply this whole entire thing, left side and right side, by a 2 in order to make that a 6. How am I going to make this 2 right here, this 2y, into a 6y? What am I going to do to that? Multiply it by 3. So I'm going to multiply everything by 3. That's a key step to this. Everybody got that? All right. So now, let's rewrite it with us multiplying all that stuff together. So if I multiply everything here by 2, I get a 4x, I get a 6y, and I get a 16. Multiply everything by 3, I get a 9x, I get a minus 6y, and I get a minus 3. All right? Now, it's set up perfectly for us to do elimination, isn't it? Yeah. Just had to do a little work, had to manipulate it a little bit, right, to make it so that it will eliminate. But it will. So I got to add up all my columns. So if I add up all my columns, 4 and 9 is 13x. This is where the elimination takes place right there. That's why they call it elimination, for that one step right there. Equals what? 13. That's easy. X is 1. All right, so that's one of my answers. Now we're going to write the answer as an ordered pair. I just like to circle it just so I remember where the x is. Even though this thing's called elimination, what's my next step, though? What's the name of the next step called? It's substitution, right. So technically it's elimination and substitution, but the first step is elimination. So did you get it? Okay, good. All right, so what we're going to do is take that 1 and put it into either one of these equations. It does not matter which equation I put that 1 in for. I don't know, which one would you like to put it in? Yeah, maybe the top one. I mean, even though 8's a bigger number, everything's just all positive up there. So it's probably the easiest one. But doesn't matter. Doesn't matter. I could put it in I could put this 1 in for this x right here on the bottom one. It would not make any difference, all right? But we're going to pick the top one. So let's do it. So it's 2x, or 2 times what? 1 plus 3y equals 8. And now it's simple, basic Algebra 1, pre-algebra kind of stuff. Okay, so that's a 2. Now let's just do this in our head. Is that all right? This is a 2, so let's get rid of it. What are we going to get? Subtract a 2 from both sides, right? We get a 6. Divide both sides by 3, we get 2. So that's basically my answer right there. But we write it as an ordered pair. I would not mark it wrong if you didn't write it as an ordered pair, but it's good to get into that habit. So it's 1, what? 2. That's it. That's your basic, ordinary, everyday elimination problem, okay? Nothing real tricky about it. There's no fractions. The only thing a little tricky about it is you had to multiply everything by a number to get those to eliminate, all right? But I consider that a normal, everyday kind of elimination problem. It's not the easiest kind. The easiest kind if it would already have been set up like this, all right? But there you go. So I have made up the quiz, actually, last period. I made the quiz up. Guess where I got the problems from? Did I make them up all in my head? Nope, got them from the book. They are straight exactly from the book. I'm not going to tell you which ones, but they are all from the book without any changing any numbers or anything. All right? All from the book. So this could be on it. Who knows? It's from the book, right? You never know. All right, let's do 29. Did somebody write these down so I remember which ones to do? Because I'm going to flip this page up. All right. So I already did 27, so I'm doing 29, 30, 34. And with my memory, I probably won't even remember that. So we're doing what, 29 now? Okay. I remember that. Alex, lay it on me.
4x plus 9y equals 8. 2x minus 6y equals -2.
Okay. I would get rid of the x's in this situation, even though this is plus or minus. Okay, yeah, I think it's a little bit easier because you only have to change one number, right? You don't have to do both. If I did this, I would have to change them both, all right? What would you change that to if you did? What would I turn that 9 into and the 6 into? What's the smallest number that 6 and 9 divided evenly? What is it? 18, very good. So you could do that if you wanted to. That's fine. It's no big deal. But you'd have to multiply this by 6 and multiply that by 9, right? But in this one, if I wanted to get rid of the x, what's the one thing that I can do? What's the easiest thing I could do? Multiply this by what? Not by a 2, by a -2. Now, technically, you could multiply by a 2, but then you wouldn't add the columns together. You would do what? You would subtract the columns, okay? So you could do that. I mean, some teachers teach that. You subtract the columns from each other, all right? So that would be fine. But I've been saying adding. The book even uses that word, right? Addition, add the columns together. So let's do it that way. All right, let's rewrite. Well, the top stays the same. We didn't mess with the top, so we don't change that. Just keep it the same. Now the bottom, multiply everything by a -2. Be very careful with negatives, all right? So this is going to be a -4x. What's this going to be? It's going to be -12? Positive 12, right. It's going to be positive 12y. And what's that going to be? That's right, because I forgot something. What did I forget? I forgot to put the negative there, didn't I? All right, so absolutely right. It's going to be positive 6. Did you guys catch that? Got to make sure I don't make any more mistakes like that because I could have gone through the whole thing and then messed it all up. So if I can make that simple little mistake, you could too, right? I even specifically said, make sure that you multiply by a negative, and I didn't even put a negative there. Well, anyway, we all make mistakes. What's that? He would have caught it? You think so? So there you go. So that cancels out. Let's add up all the columns. What do we get here? What's that? 21? 21y. And what's that? 14. We get a fraction, but that's okay. Divide by what? 21 by 21. And what goes into both of these? Huh? 7 goes into this, right? Twice. 7 goes into this 3 times. So it's 2/3. And you could get a fraction on this quiz, all right? I'm not saying that it's out of the realm of possibility. Did you guys choose one where you get a no solution or all the real numbers? Because you could have that as well.
No, they didn't.
Okay. All right. Yeah.
They wanted to put it in.
I lost my music.
You did.
Huh?
I said you did?
Yeah.
Oh, well, I don't know what to tell you. You didn't turn it into me? Oh, well, sorry. Don't know what to tell you. Sophie probably stole it from you. Just threw you under the bus, didn't I? All right, let's do this. Let's solve for x. So what are we going to do? You could put it in the bottom one or the top one. It doesn't make any difference. Which one do you want to put it into? Let's put it in the top since it's got all positives right there. All right, it does not matter, though. So it's 4x plus 9 times what? 2/3. And this actually works out kind of nice and easy, doesn't it? So I've got 4x plus, look what happens here. This 3 goes into this 9 how many times? 3 times. 3 times 2 is 6. Easy. Subtract 6, you get 2. Divide by 4, and you get a half. And there's your answer. Is that the answer I gave to you?
Yeah.
Yep. So it's 1/2 is first, 2/3 is second. Put it as an ordered pair, and there you go. Okay. Everybody good with that? These are all eliminations. So if anybody's actually watching this on YouTube, which I have doubts that anybody is, but if anybody is, this is the homework from last night, which is 3-2B, and it's all by elimination. We'll hit some substitution and graphing after we finish these up, okay, because that's also going to be on the quiz. All right, Alex, give me number 30. Oh, you put the book away? 177, page 177.
Here.
All right,
What was it?
30.
4x plus 6y equals 5. And 8x minus 9y equals
3. Okay. All right, here we go. Seems like we already did one like this. Is this any different than the one we did before? Let's go really quick, okay, on this one then. Is this supposed to be -3 or not? Oh, it had a negative. So this is the same problem except the other one had -3 and this one doesn't? Oh, really? That's a little different because I got a 4 and an 8. Because I had a 4 and a 2 before, didn't I? Or something like that. Yeah. All right, so let's do this. Let's multiply this by a -2. Yes? All right, let's do it. So let's go real fast. -8x minus 12y equals -10. 8x minus 9y equals 3. Eliminate these. What's that going to be? -21 again? And that's -7. Divide that by -21. What's that? 1/3? Okay. Let's put it in for one of these equations. Put it in the top one. Yeah, it doesn't matter. 4x plus 6 times y, which is 1/3, equals 5. All right, so I got 4x. What happens here? That 3 goes into that, what, twice? So plus 2 equals 5. Subtract 2. 4x equals 3. Divide by 4. X is 3/4. There you go. Easy as that. Oops. 3/4, comma, 1/3. Is that the answer I gave you? Everybody good with this? Yeah, this is a piece of cake now, isn't it? One more. Does this one come out? This one comes out to like all real numbers or all no solution or whatever. All right, so let's do that one. What is it? 34, Alex?
Yeah, all right, yeah, 34. X equals 2/3y, and y equals 4x plus 5.
4x plus 5? Okay. All right, here we go. Again, we're doing this by what? Elimination, right? So you have to do it this way. And I will check on the quiz if you do it. I'm looking at the steps, all right? So definitely don't just write an answer down because you looked at somebody else's paper. Don't do that. Nobody would ever do that, would they? No, of course not. So there's no way in the world you're just going to be able to look at it, write down an answer, all right? So first of all, if you don't have any steps at all, it's going to be wrong. All right. Secondly, I'm going to look at your steps and I'm going to make sure that you're doing it by either substitution if it asks for that and by elimination if it asks for that. These ask you to do it by elimination. So let's get rid of that fraction. Don't like the fraction. How do we get rid of that fraction? Get rid of the denominator. How do I get rid of that denominator? Times it by what? Yeah. Multiply that by 3. Now, you can't just do that to the right side. You also have to do it to the left side as well. Okay? So that should make things look a little bit nicer, but we're still going to have to do a little bit of manipulation with this. So what do I got? 3x equals, that cancels, equals what? 2y? Well, it says do it by elimination. Right, it says to do it by elimination. So on the quiz, if you substitute as your first step, it's going to be wrong. And I hate to do that. I hate for you to get a right answer and then me mark it wrong. Oops. But That's what's going to happen because you got to follow the instructions. And the instructions say, if I can reach my pen here, the instructions say to do it by certain methods. So you got to do it by that method. All right. What I would do on this, just to kind of keep it in that whole elimination range, is I would put everything on the left and set it equal to whatever number. So I've got a 3x. How would I move that 2y over to the left? I would subtract a 2y, and what's that equal to? 0. So that's what I'm going to start off with my elimination. All right. I'm going to do the same thing with this. I don't like it in this form right here because I want the x's and y to be on the same side, and I want the constant to be on the right side. So you could move the 4x over to the left, but what would that give you? That would give you a negative 4, wouldn't it? And that'd be okay, I guess. Let's do it. Who cares? So it's negative 4x. Move that over there. And so what do I get? Plus y equals what? 5. All right. And that's okay. I could do that. Yeah, let's just do it. I don't want to confuse you any. What I was thinking about doing is just doing this. Take this y, move it to the right, and take the 5 and move it to the left. Then I would have 4x minus y equals negative 5, just to get that 4 positive. But it really does not make any difference if it's positive or not. So let's just keep it like this so I don't confuse you anymore. All right, what's going to happen here? So, yeah, let's multiply. Well, let's not put that line yet. Let's multiply everything by 2. That's what I would do. Why? Because I want, say I got a negative 2y already right here, and I definitely don't want to change that. I'd have to change that to a 12, right? And I'd have to multiply the top and the bottom by something, which is just a waste of time, I think. So multiplying that by 2, I think, is the easiest way to do it. So let's see what we got. So I got 3x minus 2y equals 0, and I've got negative 8x, what? Plus 2y equals 10. All right? Everybody with me? Eliminate. Boom, right there. Negative 5x equals 10. X equals 10 divided by negative 5 is negative 2. I thought this was one of the ones that, no, I guess it doesn't. I thought we were going to do one of the ones where it was no solution or all real numbers. That's what I kept on looking for that this whole time. I'm like, that's not going to happen.
There's 33.
Okay. All right. So let's solve for y now. So I would do this. See this one right here? It's already got y by itself. I mean, I could go to any of these equations. It doesn't matter which one. But to me, that's the easiest one. So let's do that down here. So y equals 4 times x, which is negative 2, plus 5. That's negative 8 plus 5 is negative 3. And there you go. Write your ordered pair as negative 2, negative 3. So that was a little bit different because you had the fraction right here, but it was pretty easy to get rid of the fraction. It was also a little different too because I had to rearrange some things, right? So that's why this is, what, is it the last one? Yeah. That's why it's the last problem in this little section because it is a little bit different than what we did before. But really, each step wasn't that hard. Everybody good with that? All right. Let's do this. You got the book open, and I took the problems from the book. I didn't take the problems from the worksheet. All right. So the worksheet was good practice for you, but I did not take the problems from the worksheet. So ask me some problems either on section 3.1 or 3.2, the ones with the graphing or the substitution ones. Let's do a couple graphing ones. We got like 15 minutes, okay? So we should be able to do some from both. Let's do some graphing. Let's go back to 3.1. Take a look at those problems. So I basically took the problems starting at 15, anything from 15 to 36. And I'll tell you right now, I did not pick a graphing problem where the answer came out to be a fraction, okay? So like on number 35, let's see, 36, 35, they're all fractions. Looks like they're the only ones that came out to fractions. So 35 and 36 on the graphing are not on the quiz. I'll tell you straight up, okay? So you can ask me any of the other ones. Which ones do you want to do? Pick some out. You pick them.
No, I said Al.
Oh. Alex probably already knows how to do them.
So why?
Which ones are we doing?
Let's do this. Let's pick 22. Alex, you got the book open?
22.
On page 163. 22. I don't even know if this is on the quiz or not. I can't even remember. I don't think it is. But 3x equals what?
Equals 7 minus 2y.
2y. Okay. What's
2x equals 2 plus 4y.
all right? And this says to solve by graphing. And I give you the graph. I give you a graph on the quiz, little empty graph paper thingy. All right, so that you can graph right on the quiz and you can be very accurate. All right, so before we even graph, before I even think about graphing, what am I going to have to do to both of these equations? Put it into what form?
Y.
Yeah, y equals mx plus b, or slope-intercept form. Okay, so I want to put it in there. So I basically just want to solve for y. So let's do that. Let's take this one and let's solve for y. What would you do first? If I want to solve for y in that first equation, I want to get y by itself. What am I going to get rid of first?
3x.
What? 3x is on the other side. I got to get rid of the stuff that's on the same side with the y.
So you minus the 7.
Yes, get rid of the 7, okay? So subtract the 7 from both sides. So what would that give me? That would give me 3x minus 7, correct? And then equals negative 2y. Everybody see that? I probably should have written it here and then just dropped everything down, but I just tried to save myself a step, okay? And then get y by itself, divide by negative 2. Divide everything by negative 2 over here. So that cancels. So what's y equal to then? It's 3 over negative 2. What's that? It's negative 3 over 2x. And this is negative 7 over, oh, that would be a terrible one to do, wouldn't it? Well, that's all right. You still got to, yeah, that's okay. We can still do this one. Negative 3, where am I? Right here, plus 7 over 2. And we have to graph that. Well, first of all, did we do this in class? It seems like we might have done this together in class. I don't know.
Yeah, I think you said.
So what is 7 over 2? How do I plot that point? That's my y-intercept, but how do I plot it? What is 7 over 2? It's a mixed number, isn't it? What is it? 7 over 2. You got to know how to do this. 2? 2.5? Look, 2.5 would be 5 over 2. It would be 3 over and 1/2. Okay?
I thought we times it by 2 over 1 and then it would make it possible.
Yeah, but then if I multiply that by 2, then this would be a 2. Then I don't have y equals mx plus b, right? So this is the way I'm going to graph this. I'll put it in a little box. That's what I'm going to graph. But I just want you to understand that 7 over 2 is 3.5. All right? Let's do it over here. Let's get y by itself. So subtract a 2 from both sides. So I got 2x minus 2 equals 4y. Divide both sides by 4. Divide this by 4 and this by 4. So what do I get? Y equals 2 over 4. What's that? That's 1/2 x minus what? 1/2. I don't think we did this one in class, to tell you the truth. It's not my answer. Why did I put them in boxes? Just so I could what? Just so I knew that that's what I was going to graph. Okay? So let's just put these basically on top of each other like this. Let's get a graph. Oh, it's got to slide way up here. There's my graph. Let's go back down. There we go. And let's make it a little bit bigger. Kind of hard to graph, small graph like that. All right, so here we go. We're ready to graph. Let's change colors. Let's do the first one. So what's the y-intercept? It's negative 1/2. So where do I go? Right here, halfway. Why wasn't that red? I thought I made that red. Let's try it again. There we go. All right, there it is right there. Okay, so there's my negative, or this is my y-intercept. And my slope is 1 over 2. So I start at the negative 1/2 and I rise 1. Does that mean I go up to the 1? No, I go up 1 place value. So if I only go up to here, that's a half. So there's my 1. Okay? And then I go 2. 1, 2. So it's right there. Sometimes if the points are too close together, it's hard to be super accurate on it. So let's do it one more time. Let's rise 1 and then run 2 again. And just for the fun of it, let's go down 1 and to the left 2. Do they all line up? Yeah, they should. All right, so that's basically what it looks like. So what am I looking for on your answer? I'm looking for 3 things. I'm looking for this, and I'm looking for this. All right, because you're going to have to change it to y equals mx plus b. I don't think on the quiz, I don't think that I actually gave it to you already set up, y equals mx plus b. I think I gave you 3 problems like this, and on all 3 of them, you had to do some manipulation to get y by itself. Everybody hear what I said? All right, every one of these 3 problems for the graphing, you had to get y by itself, I'm pretty sure, on all 3 of them. All right, so if you have this, this, and this, then you got the problem right. By the way, while I'm thinking about it, I only gave you 9 problems. I usually give you 10. So basically, number 10 is a freebie. All right, so still going to take off the same amount of points as I normally would, but I only gave you 9 problems, 3 from each, 3 graphing, 3 substitution, 3 elimination. That was nice of me, wasn't it? Yeah, you're welcome. Sure. Go ahead. Oh, I didn't do the other. Oh, my goodness. Thank you. I'm confused too. Absolutely right. I only did 1 equation. What am I doing? I got to find a daggone solution, right? Alex is the only one that said anything. All right. And he's not even paying attention. He's like doing his housekeeping over there. All right, let's do this. What did we say this was? 3.5. So let's go up what? 1, 2, 3.5. So we put a point right here at 3.5. The slope is negative 3 over 2. So watch. I go down 3. 1, 2, 3. Go over 2. 1, 2. Check this out. This makes it super easy because when I went down and over, it hits right on the intersection of the other line. It doesn't always do that, but in this one it does. So we still have to graph the lines, but now it makes it without a shadow of a doubt what the answer is. Okay? Yes.
Did we bring our own ruler in?
You can bring your ruler in. Absolutely. Bring a ruler in. All right, so what's my answer? It's that intersection of those 2 lines. And what is that? 1, 2, what? A half. So over 2, up a half. That's your answer right there. Now I finished it. I don't know what I was thinking. I was getting ahead of myself. Everybody with me? Yeah, that's pretty easy. So you just graph them. Now, I'm not going to do any more of the graphing, but what if your 2 lines came out to be parallel to each other? What would your answer be? Nobody paying attention? It's no solution, right? Because if they're parallel, they don't intersect, so there's no solution. What if the 2 lines are exactly the same lines? Then it's all the real numbers, okay? All right, let's do a substitution. Anybody pick out a substitution one? No? So we go back to the other lesson, 3.2. And substitution. So substitution is 11 through 22. Any of those you want to do? Pick one. 18? Nah, let's not do that one. I told you to pick one. Let's pick 21. You going to read it off to me, Alex?
2x plus 2y equals negative 1. Then 3x plus 4y equals 0.
If I told you to do this any old way, I'd probably use elimination on this, wouldn't you? Yeah, probably. But they don't do that. All right. I should have done an easier one first, but that's okay. You can figure out the easier ones. I'll do the harder one first. So what you could do, you could either solve for this x or solve for that y, solve for this x or solve for this y right here. What do you think would be easier? Don't know. Tell you the truth. Is there one that's any easier than the other? I don't think so. So, yeah, because you're going to get a fraction no matter what. So let's just do this. Let's just solve for the first x right there. Is that all right? Everybody watching? Anybody still here? So let's get x by itself. So I'm going to rewrite the problem. Let's get x by itself. So I'm going to subtract a 2y from both sides. And I'm going to divide by 2. So x equals, this is negative y plus 1/2. Okay? Now, what you have to do, you could have picked whatever variable to solve for first, but now what you absolutely have to do is you have to take this x right here, put it in for the x in the other equation. So you need to put it here. Don't put it back into the original equation that we did this to. All right? Put it into the other equation. So let's do it. It's going to be 3 times x. What's x? Well, it's negative y plus 1/2. And then write out the rest of the equation. Plus 4y equals 0. It might have been easier to solve for y. You're right. But I don't know. To solve for this y?
Yeah, because then the half would go into an even number.
Yeah, that's true. Right. You're absolutely right. Didn't think about that. But that's right. We're already committed. So let's finish it up. It's going to be a little ugly with fractions, but it's not going to be that hard. So here we go. Let's multiply. So that's negative 3y plus 3 over 2 plus 4y. This comes out super easy. That fraction didn't even bother us. Watch. Do you see why? Negative 3y plus 4y, what's that? That's 1y, right? Plus 3 over 2 equals 0. See that? So y equals negative 3 over 2. So we were all worried about nothing. So that's what y is, but we got to find what x is. We didn't really find x, did we? So we got to plug that back in. Now we're going to have to do a little bit of, but it comes out kind of easy anyway. So we're going to plug this y in for this y and solve for x. So x equals, watch, it's negative y. So it's negative 3 over 2. Yes? So what's negative 3 halves? Positive 3 halves. Oh, this is easy. Plus 1/2. What's the common denominator? 2. Or add the top. That's 4. And what's that? It's 2. So x is 2. So the fractions look scary at first, right, when we started doing this stuff right here, but really, we didn't even have to worry about them. So it's 2, negative 3 over 2. That right there is your answer. That. Okay? Looks like I wore you guys out. Looks like you walked like 15 miles on a hike with me. It's not that bad. You're right. Mentally, I mean, doing things like thinking mentally can sometimes be more physically draining than actually doing physical things. Absolutely. Okay? Don't, what's the word I was trying to think of? I can't. Anyway, but yeah, don't diminish. It's not the word I was thinking of, but I can use it. Don't diminish how hard it is to think about stuff, right? And that's probably why you don't do anything. If I asked you, if your homework was to go up and run up a mountain and down a mountain, some of you guys would do that any old day, but you wouldn't do 10 math problems because it's a lot more draining. It is draining, absolutely. All right, so, but I tell you what, when you do them and you know how to do them, it's actually kind of rewarding. Do you feel that way at all? Has anybody felt that way? When there was a problem you couldn't do and then you worked on it and you're like, oh yeah, I got it. Doesn't that feel good? Yeah, I think it does. I think that's why it drew me to math. I am not any kind of great mathematician. We've talked about that before. But man, it's just fun when I get a problem that was a little bit tough, a little bit difficult, and I really had to think about it. And then I finally got to work it out and it came out right. Man, it's a great feeling. It's like when I'm hiking up a mountain and I'm tired, my legs feel like tree trunks, I'm thirsty, I'm sweating, whatever it is. You get to the top of the mountain and you see that view and you know what the first thought comes? It was worth it. You know, you don't even think about how hard it was to get to that point. It was worth it. It's almost like this, kind of. I mean, I'd tell you the truth. I'd much rather climb up a mountain and see a view than do a math problem, tell you the truth. But it has its own reward. So anyway, there you go. All right, that's the quiz. So there's 9 problems, 3 of each, 3 graphing, 3 substitution, 3 elimination, and they're all from the book. I don't know what else I can do, but hold your hand as you write the problem out and get the answer, okay? I can't do any more than that for you. So there you go. Study for it, please be ready, and then we'll take that tomorrow.